So I'm building a data pipeline, data platform. This is the markdown file for it. So I'm calling it crawl nexus. Going to be ingesting loads of data and doing a load of stuff. So I've got the proms, just get the data, clean it up a little bit, get it into a better shape, and then dedupe / entity resolution, all that sort of stuff, representing it in a canonical model. And I'm going to have an OLAP and OLTP. OLTP is Postgres, OLAP is ClickHouse. You can think of this as it's optimized for rows, get me my data on my row, versus give me all of the data in a single column so I can do some analytics on it. And then all the architectural decisions that I'm making as I go along. And then I've got some architecture diagrams, all of these different sections for the data platform, which are all documented in docs here. Key decisions, more information about the overall architecture flow. So you've got the orchestration is Dagster. That's going to be trigger all the monitors and all the jobs in sequence. So detecting that a external data source has been updated and we need to pull it in. The thing that actually ingests all that data is going to be Airbyte. The thing that transforms it is going to be DBT, bronze to silver to gold, resolution, entity resolution, duplicates and links records across all the sources. And then once that's done, the Airbyte is used again. So here it's ingesting data into ClickHouse, but then it's used again here to get the data into Postgres. And then it will all be served up in a Postgres database with PG search, which offers BM25 full text search, and then ultimately we'll expose it via some API. At the moment I'm thinking fast API. And you can see here a linear pipeline of source data comes in so that a customer can then access it via an API on the right. And component and their roles, so storage, OLAP, ClickHouse, OLTP, Postgres, why we've chosen each one, the architectural decision records that each part relates to is on the right. Quick links to, so these are linking into other sections of the other documents, and then how we go about refreshing data, what it's not trying to do, and the status of some of the stuff that we've done. So here are all these sort of documents. There's a quick little browse at them. So I've got all this information over here as well. But what I want to show you is the approach I'm taking to figure out how to build this. So I've done this initial what are my objectives, then chatting with the AI to come up with what will this data platform be comprised of architecturally, then really documenting that very well, which is here, data sources, architecture, tech stack, data layers, canonical model, entity resolution, pipeline for the data, data quality, data deployment, and open questions of things that haven't been resolved yet. And then architectural checks. This is how I'm going about building it. So if you look at architecture checks task, I'll drag this over, scroll up to the top. So purpose, validate each component of the crawl nexus data platform runs locally via Docker before integration. So if this is all the shit that I'm going to use, does it actually work? Can I get each one of these to work in isolation? Because having Claude just run away and check it is pretty trivial. Whereas me trying to piece it all together and merge them in different combinations and eventually full everything all in one combination, that's a lot harder. So if I have Claude just check, can it run ClickHouse and check that it's all working? So here I've got how do we set up ClickHouse, and then one example is when it was doing Airbyte AB, these guys don't actually have a Docker container anymore. And initially my research was saying, hey, yeah, it's going to be Docker Compose, Docker container, but then when I asked it to go and do the research for this one, what it found is that actually AB, Airbyte, no longer does Docker container, it's now ABCTL, some sort of control layer with a CLI thing. So it's like, okay, well, I'm glad I told it to do this research. So before carrying out each of these things, I told it to go online, do some research, use Firecrawl itself to go and grab a load of information on the internet and plan out how you're going to implement it all. And then once it's got that plan, then I said, right, check back at this document here again, this one, and this one here, and the research for each respective one, and spin up. At the beginning I did 0 to 5, 0 to 6 all at once. So I had 6 copies of Claude code running in parallel, all doing each of these ones in parallel. and each of them would receive injected information about this, and then they would look at their own respective research document. So coming back to this one, this is how it spins up all of Claude Code. Health check, is it working? So if we spin up the container, can we poke it? Does it respond? Does all the right sort of stuff respond? And are we getting back information that we expect, like the version information? If we ping it, does it respond? If we do some sort of sample query after putting some crappy data in there, does it work? Here we're actually just doing select one. So now we know that ClickHouse is fine, and then we can do the same thing. Parade DB is just like Postgres plus this PG search optimization BM25, or what the fuck it's called. Then checking Firecrawl, Airbyte itself, Dagster, that's the orchestrator. DBT check, that's the transformation. And then Airbyte sync check, this one's interesting. So number 7 is not just like a flat do these individual pieces work. This is, let's put ClickHouse together with Airbyte. Wait, shit, I got confused. Airbyte's the orchestrator, what? Just double check that. No, it's in here, isn't it? Make sure I understand this properly. Fuck off, too many windows. Alright, so Dagster is the orchestrator, according to this. Airbyte is the thing that ingests all the data, like CSVs, APIs, fire crawling. So this guy ingests the data and gets it into ClickHouse and then into Postgres. Oops. Whereas Dagster is the thing that says, hey, we know that this CSV in this other location here is updated every X day of the month, sort of bullshit. So let's just run that automatically. Cron and orchestration, effectively. So if we go back into this guy, because that was kind of implying that Airbyte is the orchestrator, which doesn't really make sense. So I need to have a little look at this one a bit closer. But yeah, putting these together. So ClickHouse, take data from that. Oh, okay, I see what it's saying. It's the orchestrator that gets data out of ClickHouse and puts it into Postgres. Yes, that's true. The orchestrator for the entire system is more like Dagster, because it's main entry of triggering shit. But yeah, this thing's gone away and done all this research. And then here we want to see if we put ClickHouse in here with Parade DB, and then also Airbyte, which is done through that AB CLI thing. Can we get all that to run? And we can have health checks and seed the ClickHouse database, set up the Airbyte connections, and then actually do a test usage of can we pull data from one and put it into the other, and this all works. So it's like, great, okay, well, if I get it to review these documents again, I can get it to shout all of these ones that are in green for like, what other combinations should I be checking? And that's when it updated this document again, which is from, so success criteria, so I think here gap analysis, so like what's missing. This is what we're doing, trying to get data from some source, feed it into ClickHouse as just like whatever its original shape was. That's why it's called bronze. Fuck you. Transform it with DBT to make it a bit better, and then finally put it into its final form where we've deduped and identified which entities map to each other. This bit here, silver, is like, this is the schema of the data that we want. It's in the right schema as well, but we've also sorted out all the overlapping shit, and then we feed it into Postgres and eventually serve it out through a fast API. 1 second. So where I'd gotten to is this overall architecture here, and what's currently not really proven in the little tests and combinations I've done so far. So Dagster is the thing that kicks off the work. Core transformation architecture, if this breaks, no problem. So I'm not too sure what this one's referring to here now. Dagster to Airbyte. Can Dagster request to get data from a CSV, trigger off the job, and then feed it via Airbyte into ClickHouse, and then DBT transform that bronze data into silver and gold. So there's all these different bits, and then the next checks 8 to 12, Dagster, DBT, ClickHouse, transformation orchestration. So all of these things, testing them in isolation like this, there's no way a software engineer before would have done all of these sort of checks. You just don't have the fucking time. You would just try and build it all in one go, or most of it in one go, and then just have a hard time trying to figure out what the fuck's going on when it all doesn't come together properly, right? Surely, because there's just not enough time to do all of this. But doing it this way, I'm like validating whether or not I even want these things in my overall data platform. Because if one of these don't really perform, or it seems a bit flaky or something like that, then, or it just looks a bit shit code-wise, or it identifies from the research that, hey, this actually hasn't been updated in a long time, things like that, then I can boot it out and swap it out for something else. So yeah, it's fucking amazing. And then once I've done all these 12, I will then have Firecrawl as a source of data, Airbyte not transforming it, but feeding it into ClickHouse, which is the last part. And then I can just, now that I've learned all of this information here, I can have AI go through it and then compile it into a final sort of architecture and then produce that. Because what I've had it do is pretty much these main sessions here. So Crawl Nexus, this one, maybe I'll skip over that one for now. So this one here, the last prompt that I just fed into it was a load of text from the previous session. So now that we've done 0 to 7, let's do it for the other ones, and that's what produced all the documents for 8 to 12. What it's done here, I asked it to look at the research documents for 0 to 7, evaluate them, and then feed the compilation of all of that into a sub-agent. So Claude Code will spawn a Claude Code effectively, feed that information in, along with the data platform MD document, and I think that's it. And then each of these agents here will then go away and do research by themselves for whatever their respective task is, right? And it's gone and used 22 of its own tools, like crawling the internet, maybe spawning up its own stuff and that sort of thing, and then it's used 90,000 tokens, 94,000, 99, 55, 117 for all of this work. And it's documenting all of the research about how is it going to attempt and do this. And all of those run at the same time in parallel. Here's the information about each of them. Key findings, DAGs to DBT, versions, has blocking assets, checked by default. All components have native ARM64 support, so it's all good. Legacy, Airbyte resource is deprecated, should be using this. So it's found that somewhere in the previous 0 to 5 architectural checks that actually that's not the right way anymore and it should be doing this. So that's fucking awesome. Critical findings, integration, DAGs to DBT, translation map, blah blah blah. So all this sort of similar stuff, right? Yeah, there's no way I'd be able to do something like this before. And now we've got all these research documents. So then the next part is, now that I've got all of these research documents, is to kick off actually going away and doing the work. So I've got a research document. Here I had a research document, but then I went and produced these health checks and tests and a README and the Docker Compose where it's suitable. But another thing I want to do here before I run actually using those individual research documents and in a similar way, reading this data platform document and the individual ones inside docs, compiling that information, and then spawning 5 sub-agents to do these 5 new research tasks, having each of them ultra-think, so using a lot of tokens, using sequential thinking, which is like a sub-agent of itself thinking about each individual aspect, using context 7 for any of the dependency stuff so you can think about the latest version of the documentation, Firecrawl so you can go back onto the internet to search anything that seems erroneous, and reference each of their own respective research MD files that are now being created, and the architecture checklist, this one here, research, like look at all that information, right, all that's being fed into each of these, that all run in parallel, and the goal is, like before, to come up with a Docker Compose for the given architecture and the health check and test usage sort of scripts, and then once that's done, spawn up another new agent, and that agent will then report back the findings from 08 to 12. But before I run this, so I've done this one here which produced all the research documents. This one here is about to run, and then this one over here is now finished. But look what I asked you motherfucker. Control O, Control E, hopefully it will show me. Yes it does. So in this one here I gave it a load of information. So, no. So it compacted the conversation because there was just too much stuff. Hopefully I can scroll back. There's a bit of a scroll bar here, so it should let me. But it's done loads of work. I can see some of these grey bits here where I put my requests. So just trying to find the most recent one. Here we go. This is probably it. So this, oh no, it's not this. So effectively what I did here is like, hey, look at all of these solutions here and look at how they're contradicting each other, different versions of stuff, things that may be outdated and all that sort of thing, right? And then from that, produce me a new document. Come out of this view for a sec. I'm wondering if I'm looking at the wrong window here because this is talking about data platform 09. Ah, no, sorry, it's this window here, cross-analysis research. So this is the fat-ass prompt. So I fed in the information from the previous one. So the one that did the producing of the research documents was this session that just got compacted. So that produced the research MDs. It's about to run them, but before I let it do that, this guy's doing the cross-analysis between them all and finding all these deprecated things. So yeah, I did point it out, just got a little bit confused about which window's which because I'm running too many at once. But yeah, this thing's now properly evaluated all of them and found out all of the contradictions. So before I run this, I can say, okay, go and update all those research documents so that they don't have these contradictions and that they're all using the latest approach as we have found from this research cross-analysis. But I'll read this first to make sure there's no bullshit in it and also read its response. So if I scroll up, here's my request, and then it's gone through and done all this. So I'm going to read all this to make sure it makes all sense. And if it all looks good, then I'll say, hey, yeah, go update those research documents, and then I'll fire this guy off that will then go and hammer through and really use a lot of fucking tokens to produce it. And once I have all those, then I could just do the same sort of thing again. Research all of these implementations, along with all the other ones, reproduce another sort of cross-analysis thing, and a plan of how you're going to make the final all-in-one, all bells and whistles, based on the architecture check task, and the data platform, and all the sub-documents. Research for all of them, pass those into next sub-agents, do this like initial research in, say, 3 sub-agents, and then take all that information, pass that into another 3 sub-agents that are then going to evaluate each of these. And there's 12 here, 3, so each one will look at 4 of these, and another agent will look at 4, and another agent will look at 4, and then pass all that information into another agent that then synthesizes that all together, and then spins up another, say, 2 agents that then go through and research online again, and then finally another agent that then goes and implements it all. So it's just like you're expanding it out, kind of like a neural network as well, how you have like nodes in layers and each one has weights, right? And you're tuning the weights and you have all these hidden layers, and then you eventually come and narrow it back down to like it's a cat or it's a dog, whereas the input is a picture, and then you split that out into all these different features. But yeah, it's fucking crazy. So I can produce like a complete data platform here that runs fully local with all open source tech in the correct way that they should all be implemented and used together. And I'm doing it all with AI, so I'm not writing a single line of code. I know what quality looks like, and I know how to prompt it to get it to do the right thing, and I know when this sort of compaction stuff will actually fuck me over. That's why I've got one window here with Firecrawl, another window here with this one here, Crawl Nexus, this one here with Crawl Nexus, and this one here with Crawl Nexus, and this one's Firecrawl. So it's these 3 here that are all doing work on the same thing, but I'm using multiple sessions because each one might get to a certain point, and this one's like, hey, I've only got 3% of the token space left. So instead of letting it go and then it will compact itself and then produce a load of shit, if I'm not swapping from one task to another, letting it compact is going to be bad. it makes more sense to restart a new window and copy paste some information and tell it to re-look at some stuff and use some sub-agents to re-evaluate all the information, all this sort of bullshit. But the results you get are fucking amazing.